Hello, in this presentation we are going to carry on what we started about the motor evaluation of strabismus. In this presentation we will cover the extraocular muscle balance. In general, motor evaluation of strabismus is divided into two main parts: evaluation of the motility, which we covered in the first presentation, and evaluation of the extraocular muscle balance. Nystagmus is also sometimes included as a part of the motor evaluation. In this presentation, I am going to discuss in brief the evaluation of the extraocular muscle balance. In order to understand the extraocular muscle balance, we need to know what is normal and what is abnormal muscle balance, what are the different grades of muscle imbalance, how can we detect the muscle imbalance if present, and how can we document these abnormalities. Measurement of the degree of the muscle balance will be discussed in a separate presentation. So what is meant by muscle imbalance? Normally the visual axes of both eyes should meet at the object of regard, so that the image of the object falls on the foveas of both eyes. Such accurate alignment with the formation of the image on the foveas of both eyes is what allows for sensory fusion and binocular vision. In addition, a well-aligned eye is what allows us to communicate with others. People know that we are talking to them when we are looking at them. A misaligned eye has many psychological and social implications in almost every culture. If the visual axis of one eye becomes misaligned so that the image of the object of regard does not fall on the fovea, this is defined as strabismus. There are simply three grades of muscle imbalance: heterophoria or latent strabismus, intermittent deviation, and heterotropia or manifest strabismus. Heterophoria or latent strabismus is the most subtle grade of muscle imbalance. Many of us, especially myopes, have a small degree of heterophoria. We usually model latent strabismus as a parent who is very keen that his children are well behaved and doing what is right for them. So as long as the parent is there awake, all the children will be studying and doing what they are supposed to do. But once the parent takes a nap, each child starts to do all kinds of mess he can. Latent strabismus is quite similar, in which the brain is like the parent trying to keep the eyes straight for the sake of binocular vision. But once the brain or the parent get tired, each eye or the child starts to deviate. Hence comes the term tendency of deviation. This tendency can show up if the brain gets very exhausted or if the child gets ill. In clinical practice, in order to uncover it, you have to dissociate the two eyes to ensure that both eyes don't see the same image. Since the brain is now no longer receiving an image from one eye, it will be no longer bothered if the eye deviates, so the deviation will show up. Or in other words, the brain will take a brief nap. But once you present back the same image to both eyes, the brain will quickly get the eyes back well aligned to restore the binocularity. In this child, the eyes look well aligned, but when you cover one eye, the eye deviates out under the cover. The brain simply does not mind if it gets misaligned under the cover, as it is no longer sending the same image. But once the eye is uncovered, the eyes quickly move from outside inward to fixate to the same target to achieve binocularity. Intermittent deviation is a grade a bit worse than latent strabismus. In intermittent deviation, the deviation becomes intermittently manifest even without disruption of binocular vision or without covering one eye, as compared to latent strabismus, where the deviation appears only with the disruption of binocular vision or cover. Heterotropia or manifest strabismus is the highest degree of muscle imbalance, where the brain loses control over the deviation. In heterotropia, the deviation is constantly present, It may follow intermittent deviation or start as a constant strabismus from the beginning. The deviation may show as exotropia or divergent strabismus, esotropia or convergent strabismus, or hyper and hypertropia, in which the deviating eye is higher or lower than the fixing eye. So how can we detect the muscle imbalance? Clinically, two tests can be used to detect the muscle imbalance if present. These are the cover-uncover and the alternate cover test. The common questions are how to do these tests, where should be the patient looking, and what do we look for. We will start with how can we do these tests. You need to have an occluder to cover one eye. You can use an opaque occluder or a translucent one. The translucent or Spielman occluder has an advantage that it allows you as an examiner to see the eye under the cover while the patient cannot see through it. In the cover-uncover test, you simply cover the right eye for a few seconds, then uncover it. Then you repeat the same for the left eye. You look for movement of both eyes during the cover and the uncover parts. In the alternating cover test, you cover one eye for a few seconds, then move the cover to the other eye, and then repeat that again and again. The alternating cover test allows more disruption of binocular vision and can help to uncover any latent or intermittent deviations that might not show on simple cover-uncover test. A common question is how many times do you need to do the cover-uncover test and the alternating cover test, and where should the patient be looking at each time? Both tests should be done first in the primary position, with the patient looking at a distance target, one time with the glasses on and another time without the glasses. It then should be repeated for a near accountive target, one time with the glasses on and another time without the glasses. After doing the cover test in the primary position, the test should be repeated one time for up gaze, one for down gaze, one time for right gaze, and another time for the left gaze. The test is first done while the patient is looking at a distance target with the glasses on. The distance target can be a letter on a chart for adults, or a movie or an animation for children. The test is then repeated for a distance target without the glasses. Make sure, particularly when you take off the glasses, that the patient can see the target clearly. If the patient can't see it, try a larger target before doing the cover test. If the patient can't see still, you can't do it reliably. The test is then repeated for near with the patient looking at an accountive target. It's important to ensure that the patient is looking at an accountive target, otherwise you can miss a loss of abnormalities in muscle imbalance. The near target should be held at about 33 cm from the patient's eye. For adults, a small stick with letters on it can be used. For children, you can use a colorful toy with many details on it to stimulate accommodation. Avoid using a large fixation target without any details. Fixation light should not be used as it is not an accountive target and won't stimulate accommodation. After doing the cover test with the patient in the primary position, the tests are done again in up gaze and down gaze. This is done by asking the patient to look at a distance target and tilting the head approximately 25 degrees down or up to test the alignment in up gaze and in down gaze respectively. The cover tests are then repeated for side gazes. This is done by tilting the head to the left side to test the alignment in right gaze, or by tilting the head to the right side to test the alignment in left gaze. Remember that the head should be turned just a bit before the nose blocks the abducting eye from seeing the target. Ideally, measurements in side gazes and in up and down gaze should be done with the patient looking at a distant target and with the glasses on. Sometimes, if this is not possible, or if there are little differences between the measurements with the glasses on and with the glasses off, the tests can be done without glasses, but this should be kept as a last resort. The last question is what we need to look for in cover tests. Cover tests can help to identify and differentiate different grades of muscle imbalance, such as heterotropia, intermittent deviations, and latent deviations. Cover and uncover tests can help to detect heterotropia or manifest deviation. Both the cover and the uncover parts are important. You cover one eye and look for movement of the other eye. If the eye moves, this means it was misaligned and that the patient has heterotropia or manifest deviation. If the eye did not move, this means that there is no heterotropia. If you cover one eye and there is no movement of the uncovered eye, this probably means that the patient is orthotropic. You can see here that there is no movement of the right eye on covering the left eye, and no movement of the right eye on covering the left eye. If the uncovered eye moved from outside in on covering the other eye, this means that the eye was exotropic. You can see here that the eye is divergent and moves from outside in on covering the other eye. If the uncovered eye moved from inside out on covering the other eye, this means that the eye was esotropic. You can see here that the eye is convergent and moves from inside out on covering the other eye. If the uncovered eye moves from up down on covering the other eye, this means that the eye was hypertropic. And if the uncovered eye moves from down up on covering the other eye, this means that the eye was hypotropic. So what does the patient see on cover test, and why does he move his eye? Let's assume an orthotropic patient. The image of the object will fall on the foveas of both eyes. As the image is falling on the fovea, the brain will project the image straight ahead, and the patient will assume that the object is in front of him. When you cover one eye, nothing will change. The image of the bowl is still on the fovea, and the patient thinks that the object is still in front of him and did not move. This patient won't move his eyes. Now let's assume that the patient has an exotropia of his right eye. The image of the bowl will fall on the fovea of the left eye, but as the right eye is exotropic, the patient will fall on the temporal retina of the right eye. The patient will project the image of this eye to the nasal field, and to avoid diplopia, the brain will simply suppress the image of the right eye. This means that the brain is using the image of the undeviated left eye only. When the left eye is covered, the image in front of the patient disappears. The brain realizes the image of the suppressed eye. The image of the suppressed eye is falling on the temporal retina. The brain projected it to the nasal field. So the brain suddenly feels that the image that was in front of him disappeared and moved nasally. So the eyes will move nasally to look at the image. If you ask the patient, he will tell you that the image jumped nasally and that he moved his right eye nasally to look at the object as it shifted its position. Here the right eye is deviated outwards. The patient is suppressing the image of the right eye. The patient is seeing only the image of the left eye. When you cover the left eye, the brain suddenly realizes the image of the right eye. The patient's eye is deviated outwards, so the image is falling in the temporal retina. So the patient sees the image coming from the nasal field, that is, towards his left side. So when you cover the left eye, the patient feels that the image jumped to the left side or nasally, so his eyes will move to the left side. The second thing that you need to look for in heterotropia is when you remove the cover, what will happen? When you take off the cover, you can test whether the strabismus is unilateral or alternating. In this patient, the right eye is deviated. You can easily confirm this by covering the left eye. You can see that the right eye moved inward to regain fixation, while the left eye moved outwards according to Hennig law. Now when you take off the cover, you can see that the eye remained in this new position with the right eye straight and the left eye divergent. You can repeat that again by now covering the right eye. The left eye will move to regain fixation, while the right eye will deviate out. If you take off the cover, the eye will again remain in this new position with the right eye divergent. This means that the strabismus is freely alternating. In this patient, the right eye is deviated, but when you cover the left eye, you can see that the right eye moves inward to regain fixation, while the left eye moved outward, as in alternating strabismus. However, when you take off the cover, the right eye returns back to the exotropic position, as if the patient prefers fixation with the left eye. He only fixes with the right eye when obliged to do this by cover, but once you take off the cover, the right eye deviates again. You can see that clearly in this child. When you cover one eye, the deviated eye moves to the primary position, while the fixing eye deviates. The eye remains in this new position until you cover the fixing eye. In this patient, the left eye is deviated. When you cover the right eye, the left eye moves to regain fixation. But once you take off the cover, the left eye drifts again to an isotropic position. In heterophoria, cover and cover tests can help in confirming the diagnosis. You cover one eye and then you uncover it. You can see that the eye moves under the cover, but once you take off the cover, the eye returns back to its primary position. If no movement occurs, this means that there is no heterophoria. This is an orthophoric patient. When you cover the right eye and then uncover it, you can see that the right eye did not move under the cover. This is an orthophoric patient. You notice that when you cover the right eye did not deviate under the cover. The same for the left eye, there is no movement of the eye under the cover on cover-uncover test. In exophoria, the eye deviates out under the cover, but when you take off the cover, you can see that the right eye was deviated out and moves quickly back to regain fixation immediately when you take off the cover. This is a patient with exophoria. When you cover the left eye, the eye deviates out under the cover, though you can't see it as it is covered. But once you take off the cover, the eye moves back quickly from outside in to regain fixation. In esophoria, the eye deviates in under the cover. When you take off the cover, you can see that the right eye was deviated in and moves quickly back to regain fixation immediately when you take off the cover. This is a patient with esophoria. When you cover the left eye, the eye deviates in under the cover. Once you take off the cover, the eye moves back quickly from inside out to regain fixation. Though the cover and cover test can help to detect heterophoria, alternating cover tests are usually more helpful. The alternating cover tests are similar to the cover uncover, but instead of just uncovering, you move the cover to the other eye. This disrupts the binocular vision more and allows uncovering of heterophoria to a greater extent. Similar to the cover uncover test, when you cover one eye, the eye deviates out under the cover, and when you switch the cover to the other eye, the deviating eye moves again to regain fixation, while the covered eye now deviates. With repetition, the movement usually becomes more obvious. This is a patient with exophoria. With cover and cover test, you can see that the eye deviates under the cover, but once you take off the cover, the eye moves quickly from out in to regain fixation. Now when you switch to the alternating cover test, instead of just uncovering the eye, you move the cover to the other eye. You notice that the movement now becomes more obvious. This is a patient with esophoria. You can notice a mild esophoria on cover and cover test, which gradually becomes more obvious as you do an alternating cover test. One of the main advantages of alternating cover test is that it uncovers the whole latent deviation. You can see in this patient that the more we do the alternating cover test, the larger becomes the angle, thus helping to uncover the whole latent deviation. Cover tests are also important in intermittent deviations, not only for identifying them, but also for determining the degree of control. Patients with intermittent deviation can be divided according to the degree of control into those with poor control, in which the eye deviates spontaneously without cover test, and those with fair and good control, in which the eye deviates only after cover. In patients with poor control, the eye deviates spontaneously without needing to cover the eye. In patients with good control, the eye drifts out only on cover, but regains fixation once the cover is removed, without even the patient needing to blink or to look to a near object to regain fixation. It looks very similar to heterophoria, except that perhaps if you ask the patient, the relative will state that the eye drifts out at home without covering. In fair control, the eye deviates out under the cover. However, the patient needs to look to a near object or to refixate or blink in order to regain fixation. The last question is, how are you going to document these abnormalities? Phorias are represented by the letter X for exophoria, E for esophoria, LH for left hyperphoria, and RH for right hyperphoria. In intermittent deviations, the letter T is placed between brackets. So for intermittent exotropia, you write XT with T between brackets, and for intermittent esotropia, you write an ET with the letter T between brackets. This is similar in left hypertropia and right hypertropia if intermittent. Remember, whenever you see a patient with an intermittent deviation, you need to state the degree of control in order for your report to be complete. Constant deviations are represented by the letters XT and ET, but this time without the brackets. The same for left hypertropia and right hypertropia. It is written as LHG and RHG according to which eye is hypertropic. It is customary to describe the hypertropia according to the hypertropic eye, regardless of whether the pathology is in the hyper or the hypotropic eye. So this patient, for example, with the right hypertropia is written down as an RHG, regardless of whether the problem is in the right eye or the left eye. Some prefer to write it down as an LHG with a small h instead of a capital H if they are sure that the main problem is in the left eye, which is the hypotropic eye. However, This is not universal, and many prefer to document it down according to the hypertrophic eye in every single case to avoid confusion. The muscle balance is written down in the tic-tac-toe plot, which has 9 spaces to allow writing the muscle balance in each position of gaze. We start by evaluation of the muscle balance in the primary position. This is done 4 times. The first of them is for distance with glasses, and this is usually written in the central square of the tic-tac-toe plot. Then it is repeated for distance without glasses, for near without glasses, and for near with glasses. While there are 9 diagnostic positions of gaze, many don't test the muscle balance in the tertiary positions of gaze, which are the oblique gazes. However, it is mandatory to test and document the muscle balance in the secondary positions of gaze. Now, once you have detected a muscle imbalance, you need to measure its degree. This will be discussed in the next presentation. Thank you.